Hello there everyone. So this video is going to pick up and discuss concentration of crime. This idea really came about when I was working on the 80/20 risky facilities type analysis for Excel. It made me wonder, well, can you also do a law of crime concentration-esque analysis in Excel without having to truly map data or really do anything with it? So it got me thinking and I played around with it. And here's what you see in front of you. Right now it's just an example of ag assault across 100 blocks in Little Rock for 2020. At the bottom we see the cumulative percentage of 100 blocks, and along the y-axis we see the cumulative percentage of ag assaults in 2020. What we can see here is all ag assaults are contained within about 40% of potential 100 blocks. When I say potential, I'm not going to get into all the differences in quantifying the concentration of crime on certain blocks. There's plenty of articles out there. Just Google Scholar, Law of Crime Concentration, and they'll come up, especially the Quantitative Criminology special edition on that will give you some insights into that. But we'll get into how I did this in Excel and what this means going forward in terms of identifying truly high risky blocks for different types of crime. Today we're going to use a different example. Hopefully that will also show a similar pattern. Keep in mind this is just one city, one area. And before I get into it heavily, I want to show you that even though we're going to be messing with the data quite a bit, it is still spatial in nature. So that means we can still map it at the end of the day and see where these blocks are located, even if we did not know the area itself. So I'm familiar with Little Rock, but also if you did not, you can map them. And I already did this, so I'm just going to open it up, move it over here. And what you see in front of you, let me move it squared up and I'll add a couple labels and flatten it. So we can see in Little Rock, the higher the bar, that's the count of ag assaults per that 100 block. You can see not every street segment here has it on it at all. Some have more than others, but this lets you visualize where those peaks are. What blocks actually have a high concentration of aggravated assaults throughout Little Rock. So I think that's always a cool little part that you can. All I did was map it based on the 100 blocks. So yes, take caution with this. It's not going to be the same as if you use a GIS-based platform and you had more control over how it was being visualized and making sure it was correctly projected and everything with that. This is just a one simple way of doing it in Excel, but always double check your work with that. Especially if you notice here, these addresses that got picked up, the crime data and the addresses actually are not for North Little Rock, and that identifies North Little Rock. So it's a different city altogether, but those are some of the issues that we run into that should be aware of. That's where you have to take it with a grain of salt and be familiar with your data itself. That might just have to go back in and specialize or change how that's being coded. You could potentially even use the geocoding options within Excel to get just the 100 block point, but with that, it's an easy way to go through and visualize the data for some of your high points. With that, we also had, as I exit out of this, we have the list of where the high counts are by the 100 blocks, so you could just go to Google Maps or whatever you need and look at those and just validate it that way as well. But this is what we're going to recreate with another crime type for Little Rock. Before we get into that, if you're not familiar with the law of crime concentration, this stems from a lot of Weisbord's work in a larger crime and place environmental criminology framework. Specifically, the Sutherland Address outlines the importance of this crime and place in general, and what it boils down to is a small percentage of typically street segments accounts for a larger proportion of crime. So we have, say, 5% of street segments account for 25 to 30% of crime. So we see a small section or a small subset of areas or places within a city accounts for a disproportionate amount of crime occurrence. That's what we're going to look at today. And I say other people have examined how you want to quantify that concentration. Like I said, if you just type in law of crime concentration, you have quite a few options that come up. A lot of those get into how to quantify when you have issues with the crime you're looking at, the number of street segments you're looking at, everything with that. For those who are more familiar with GIS, one of the issues that comes up is the number of streets. So this is an example, since we're using Little Rock today, of what at least Wooditch and I did. This was related to the Predictive Accuracy Index, the PAI. But what we did in GIS is when you have streets, oftentimes you have to dissolve them and make it one street file, so one line file. And then you have to go in and do breaks at intersections to identify street segments. With that, you see a reduction in the amount of streets. So the count decreases based on what you're doing there. Because sometimes you can have a street that stops from in the middle of it, from a GIS perspective, the line perspective, that you need to actually rejoin together because it is just one street. So doing that reduces the potential of how many segments there are. This one was for residential burglary, so we even selected, based on that, a subset of that to reflect where residences were located, which kicks out some streets that do not have residential land use around it. So with that, we know if we were looking at a residential, say, property crime of residential burglary, we would know the potential amount of street segments there. With that, we know if we're looking at all of the city for a crime like robbery, ag assault, it could potentially happen on any, street that had crime or address information on it. So with that, we're going to get into today is really just changing the denominator of when we're calculating this in Excel to show how you could visualize this as a first step. With that, the data that I grabbed for this example today came from the Little Rock data portal. It's for 2020 calendar year. I did the ag assault one. What I want to work through now is another crime type. So I'm just going to filter out another crime type, robbery, and work through it. This video is going to have more commentary based on it because this is something I just kind of played through and thought through the past week as I was working through that 80-20 video. After this video, I'm going to get into linking the two together because we have address level data at the 100 block within both types or approaches. You can actually use some of that valuable insight and link them together to understand potentially what's contributing to crime on specific blocks, everything with that. They can complement each other, and you can do it in Excel. And that's where I like these videos because you shouldn't be afraid of the data, and you don't need to know some of the advanced software, some of the coding syntax and everything behind it. When you have enough information in front of you within Excel, they could get a good understanding at the face value of it. So with that, let's create a sub data set. So like I said, this was all ag assault, and I used the pivot tables and everything with that already. I went ahead and already filtered to robbery, so all I did up here was change the offense description. And I'm interested in just robbery itself, so I'm going to copy. And instead of putting this in a new sheet, I want a new workbook, so Control N and paste that in there. So now, similar to a lot of the other data sets that we've worked with that I've kind of displayed, we have the date and time stamp, the number, police district, the offense code and description, the location, and then the city, state, and zip. And it has the lat and long. For our purposes today, it's not as important that we have those, so it's okay. And that's where we could use those if we wanted to down the line to make sure that it does display in Little Rock. As you remember, for some of the ag assault ones, they did pop up into North Little Rock. We would have to specify that. For now, for the first time and kind of walking through it, we're okay. So with that, some of the first steps are to separate out our incident location, because we want to change, like the top one we have here, 1415 John Barrow Road. We want it to say 1400, so we want to change it to the 100 block. Depending on the type of data you're working with, or the city or jurisdiction, the data they gave you might only be available at the 100 block rather than a specific address. Every jurisdiction's a little different with that, so keep in mind this also helps with that if you're dealing with 100 block data. The first step I would say is to go through and make sure for the incident location that you actually have a street address for each one. The ag assault data that I was working with for the example did not, so I had to go through and clean some of those up and take some out and remove them because they didn't have a full address. So that's important to remember. You still have to go through your data and make sense of it. Here I know there's a couple issues of apartments or units at the end of the addresses that I'll get rid of. If you're looking at residential burglary or something like that, that's probably going to be more prominent there as well, so keep that in mind when you're going through it. Now you might wonder, well, since I just want to take the street number out, so like the 1415, there's a few different ways you could do that in Excel. The issue that we run into when we use address information, there's multiple numbers that could be in an address. So not only the street number at the beginning, so like 200 West 6th Street, yes, 200 is the street number, but we also have 6th Street itself would be identified as a number and pulled out. So with that, and I tried it a few different ways this past week, and what made sense to me in the end, and was pretty straightforward and should be easy to follow, is just what we've done before. using the text to columns function. So I just copy and pasted this at the end, so I have some room over here with the blank columns that we can just paste the information into. So with that, one of the first steps I'm going to go ahead and go through is data, text to columns, and here it's delimited. Since we know that there's a space between each one, we can use that to our advantage. And this will become important because we'll see here, and I'm just going to, it's already set to space. You might have to change it from comma to space depending on what you're working with. If I hit next, I'm okay with how all of these are. We see that each one pulls up here. We have to remember that I always recommend scrolling down to make sure you know how far it goes across, just so if you need to extend it, you know how many you have to do. So Dr. Martin Luther King Drive goes into column Q, so we'll need to remember that's the furthest one out for now. All right, so with that, we now have our street number. What we want to do with this is round it down to the nearest 100 block. So here I'm going to insert, and I'm just going to put the top 100 block. And then our function that we're going to actually use is the round down. And I want to round down this value here, this specific cell, so I can flash fill downwards. And then I want to do 100 blocks. I'm going to put -2 in terms of how many digits it's going to go and round down to. Close it off, hit enter, and you can see here it worked out how we wanted. So it has 1400. If I flash fill down, we're going to see this work out as we had hoped. You can see it go down. Even when we get into single digits, it goes down for us. And even in double digits, it does the same thing for us. So we're good to go there. Now the next step is, remember, since we used an actual formula within this, we need to copy and paste it so we get rid of the round down part within it. So I'm going to copy and then just paste values. So now we have the actual values itself. Good starting point. So next we need to now join back the 100 block with our address information that we already took out through the text to data. So again, going to just enter another column over here, and it's going to say 100 block address. And with that, we're going to use the concatenate function, and that's just concatenate. The important part to note here is between each one that we click on, we need to have a space. So we want to have the actual spaces in it. So when we start off, we have the 100 block, we comma to separate it, we need a space between those open quotes. That puts an actual space in it, so when we join it, there's a space there like we would see in a normal address. Same after John, and then we have Barrow, another space, road. And keep in mind, like I said, we have to go down further, and since I inserted a couple columns here, we still need to go further. And it's not going to hurt the ones at the top here that we're going over, but what we want to make sure is when we flash fill down, we have everything in it. And remember that Dr. Martin Luther King Drive was our longest one, so we want to make sure it has drive at the end of it just to have every part of the address. So let's see, we're going, we're good so far, we're good. Drive, and you can see here, we are okay. What you might have noticed in a couple of examples, and here's one in particular, this one has a 7 at the end. It probably refers to a specific unit. So to make our lives easier at this point, 'cause it could match on an address itself, I'm just going to delete that, and you can see it updates over here because it still has the concatenate function working in it. And as I scroll down, there was another one up here that had I-30's fine, I-30's fine. It had another number in it, 210. So now when we update and once it aggregates upwards, we're going to see that those are similar streets, so you can actually have the count for those. With that, since this is a function that was used within it, the concatenate part, I'm going to go ahead and copy and paste so we get rid of that. Paste values. And here at this point, I think it's always important, if you want to do a quick check of it, I'm going to just put down here so I know this file, Robbery 2020. We can sort our data. With that, I want to sort now based on the 100 block address. So if I come back, even though not all my columns had a variable name, I'm still going to base it off of that, and I can always change it later if I need it. 100 block address, smallest to largest, A to Z. So as we can see here, if I come back over, the 100 block starts with a 0 itself, so we're good there. And as we go down, it's just an easy way to double check that everything is in a good position for us. Nice. So with that, I'm just going to highlight these cells here. And now I want to insert a pivot table. So I want to combine based on the 100 block address and then do a count. So how many are there across? So insert pivot table. It already has a selected since I highlighted it. I'm going to throw it in a new worksheet, so it's going to go to the left of this one. I'm just going to move it over, rename it to pivot. And now I know I want the rows within this to be the 100 block address. So we see all these generate. After that, we just want the count at each 100 blocks. So with that, we have our incident number. I'm going to just move it over to the values part. It automatically went to count, but if you need to switch it to a different value field, just left click on it, value field settings, and you can change it there. It might have done some for some reason, depending on the data set you're working with, but make sure you have your count. We're good to go there. I'm going to leave it in count. You could do percent of total, which I'm going to do in the next worksheet, but for now I like to still have the counts there, so I'm going to leave it as that and just copy it over. Before I do that, I'm just going to rename these 100 block address count robbery. All right, so as we look through this, remember we had 370 robberies in Little Rock for 2020 calendar year. With that, we see that they occurred 295, but I don't think it was at the top. So about 292 distinct addresses. I'm just going to copy these over so it's a bit easier for us to work with. So copy, just a new working sheet. There we go. So we had 370 robberies that occurred on 292 different 100 blocks. So we see that about 75-80% of the potential street segments, if we're looking at equality and we had 370 robberies, if each robbery occurred on a distinct unique street, it would be 370 potential ones. Since we have lower than that, we do see some clustering or some concentration on certain streets. About 75-80% of the original total could be used here. And I'm going to come back to that 370 mark because that is our denominator. If we're talking about concentration of crime, the opposite would then essentially be equality, to where it is equally distributed across all streets. We know that's not the case since we have 293 or 292 and not the 370. What you might wonder now is, well, where are high ones? We can do a quick sort, and we're going to do it based on our count, and we want the largest to smallest. So with that, I'm just going to scroll back up, and you see that we do have some that where it's clustered. Colonel Glenn looks like a high road for robbery, but with that, I'm going to go in now and calculate percentages and also bring in the block data so we can make sense of how robbery is distributed across the blocks within Little Rock. So to do that, I'm going to make a few other columns and just work from percentages from that and do some basic formulas within Excel. All right, so let's get started with percent total robbery. With that, so we know we have 5 in this one, and we know our total is 370. So if I just take our cell value and divide by our total, which is 370, we can see the percentage there. Keep in mind, you need to specify that this is a percentage. So I go up here, click the percent itself. I'm going to add a couple decimal places just so we can work through it, and flash fill down. If we go to the bottom, we'll see that it has all of our values, which is good to see. Next, we might be interested in, this is where when we make the table, it's going to become important. We want to know the cumulative. So with that, and I'm just going to make sure these are all in the same font. There we go, just so it's easier on my eyes. So for the cumulative, we want to add it together based on the descending order. So we have our value there, which is good, and then we have the prior value adding to the next one, and then we can just flash fill based on that, and it's going to keep going until we reach our 100% of all robbery. So we're good to go there. And I have a typo. Oops, let me get out of that. There we go. Wasn't paying too close attention. There we go. So now we have our robbery information. We know how that's distributed across. So we do see that there are a higher percentage on certain streets. Keep in mind that there's thousands of streets in Little Rock. The potential, if there was equal distribution of the 370, our total or our denominator at that point would only be 370, not the thousands, and not even the 292 addresses we did find. We need to make it the total based on what it could be if we had an equal distribution across the city as a whole. So now that we have the robbery part down, we know how that is spread across the streets we have. Let's get into our 100 block. So this is where it's important to realize that we're going to do our percent of blocks. When I have that, this is when I got into just discussing the 370. We know each one of these is a 100 block. We're not going to divide by the total number of 100 blocks we have here because that's where we already know that they already have robbery on them. We want the total potential, which is the 370, which is equal to our robberies here. With that, we still know it's smaller than the amount of street segments within Little Rock, so we're okay. If we were looking at calls for service or a crime type that has thousands of thousands, you'd have to change this a bit. But since we're looking at a crime that has fewer than the street segments, we're okay to do it this way. It's not going to work in every situation, but at a first glance, we're okay here. I'll make additional videos when we run into instances where you need to adapt this, but this is a pretty straightforward one. So we're doing 370 here because that's the potential for that. Again, change this to a percentage, move some decimal places over, and I'm going to flash fill down. What you can see here, each one has 0.27. That should be correct because each one is just a street itself. As you can see, if we go all the way down, it stops with our data. But now we're also interested in the additive effects of the cumulative. Again, I'm just going to update these so it matches the prior ones. All right. So with that, we're going to take our prior value, and we're good on the first one, but now we want to add each one together, and it increases that way for us. What we'll see at the bottom then is how many streets actually account for 100% of the robberies. And here we see about 79% of the street segments had a robbery occur on them. So that means out of 370, 79% actually had a robbery occur. So some clustering or concentration of crime across these. So we're good to go there. We're starting to see that. So keep in mind, if I left this as our denominator here, it's not accounting for the potential of opportunity. So with that, if this was the 292, and I've made this mistake when I made a couple of these videos before, and I had to go back and just re-record, if we left it as 292, it's going to equal 100% here, but that doesn't speak towards the opportunity of equal distribution. Having it here with 78, we know that all of the robberies for calendar year 2020 occurred on about 78 to 79% of the street segments. Yes, that means about 21% or so are concentrated within a couple, but with that, it's not as concentrated as we'd likely hope, but it's not terrible either. So we're going to look at this, and you can even eyeball it here that 2.7% of the 100 blocks account for 10% of the robbery. So we have some good takeaways across 6% to 20%. We're starting to see that law of crime concentration. Every city, every crime is going to be a bit different, so it's really just a way to approach and understand the data. It's not a threshold that always has to be met because it's going to vary. Every city is a different backcloth itself, so how crime occurs and where it occurs is going to differ. What we're looking at is robust findings across, so we're good to go there. But now, say we want to visualize this data. Similar to how I did the other table, I'm just going to highlight the cumulative percentages, and hopefully it generates one of the first tables that I like, the charts. I'm going to insert. Since I have these highlighted, I'm going to hit recommended charts, and with that, I want to, it doesn't have the one I was looking for, so let me see here, and it's a combo, and I want this one to be a line as well. Let's see, that's the robbery. I want that to actually be a bar. but it's not in the descending order that I want based on the counts. Oh, let's see here. See, and this is where I say it takes a bit of time, because last time I did this, it generated just for me and I didn't have to worry about anything with it. I see what I did now. So let me also highlight the count one. That will help. And now recommended. And it's a bit easier to work with now in the combination one, hopefully. Cumulative percentage. So we're good that direction. We're good here. And I'm going to update this so you can see a different one. So ideally what we're looking for is, oops, let me close out of this and come back. Let me see how I did it in the Ag Assault one. One like this. So we have our cumulative percent of blocks across the bottom, our x-axis, and our y-axis is percent there. So why is it giving me troubles on this one? We shall find out. Alright, so let's hop into this, and yes, I paused and kind of played with it and looked back and forth, but let's get into more line charts. And what we're going to have to do is select the one that we're interested in and then change up the data so it reflects what we want it to. So I'm going to hit OK here, and we're going to generate a line graph. But with that, this is where I want to change up the data. Personally, I like a darker design to it, but now let's select our data. So it's identifying this for us. But across our axis itself, this is where we have the issue itself. We don't want these values in here. It's adding them for us when we don't want that. So with it, this is where we have to specify what we want. And we want our percent blocks over here. And for whatever, edit. So with that, I'm going to select our percentage there, hit OK. We don't need our blocks on that one, so I can remove that. And you can start to see here what we're looking at. Keep in mind, I need to then, it brought in the title or the header, so uncheck that. And if I hit OK, this is when we can start to change with the axis to see what we're looking with here. So generally, this is the cumulative percentage of robbery on the y-axis here. So we get to 100% on just 78% of all the streets that it could potentially occur at. So let's change this up a little bit just so it's easier to work with. So with that, I want to format my axis. And trust me, this takes a bit of time to play with to see what you like the most, but spend some time and it will work well with you. So that's fine, that's fine. Tick marks. So here you can change the interval between the marks itself. So if I hit 10 there, it will shift it. Labels, we're good there. Distance from the axis. And then the number itself is a percentage. So there we're just helping link that together. Here we want to specify grid lines are fine, grid lines are fine. You can get rid of those if you want, or you can kind of make them a bit darker. I'm going to make it white so we can see it a bit easier. And I'm going to change the transparency. There we go. See that a bit easier. If you want to add the glow and all that to it as well, you can do that. There we go here. Axis options. And you can see here the top, it goes to 120%. I want to leave that 100%, so I'm just shifting that over. If I click anywhere else on it, you'll see that it shifts for us. So now we can start to see how that distribution of robberies are spread across our 100 blocks in Little Rock. With that, we want to clean this up here so we don't have as many values, so it's a bit more spread out. We have our y-axis taken care of. Now we want to work with our x-axis. All right. So that's fine. It crosses automatically. We're good there. We're good there with access options. On tick marks. All right. And here we go. Let's change this intervals between marks. Let's do 100 outside, outside. Didn't change. That's why. There we go. So if I specify interval units in between the labels itself, we get into 10. So you can see here it changes based on every 10 units specifically. If I want to up it to 20, we can spread it out a bit more and just see where those fall. Helps out and just spaces it out. It still tells the same story, so we're good to go there. Yes, we don't see the end, and if we tried to add each data point to it, it's going to become too jumbled to see. What I mean by that, if I add data labels, it pulls up each one. So that's why you can't really see anything. So Control Z and we're good to go there. If you have not played with the chart tools at all, you can change the layouts a couple different ways to display what you're showing. As you can see here, everything's kind of moving around as I hover over different ones. Typically, I like this one here because I can change my axis title on both sides to let you know what you're looking at, and it still has this over here. All right, cool. So we have our cumulative percentage of robbery. You can change the title across 100 blocks in Little Rock. Now, how do you map this? Because this is one part to it, which is important, but you still might want to visually see the data. And since we have the 100 block here, the quick step is to just then add city and state, and then have it auto fill, flash fill downwards. And I'm just going to highlight those, flash fill. And with this, I'm going to select our data set here, and it scrolls down to highlight our data. Going to go to Insert, 3D Map, and open 3D Maps. Give it a second, and it will pull up, and then let me move this over here. And you can see that it brought in city and state. It did not recognize the 100 block based on how I had it labeled. I can specify 100 block address, and then you have to say what it is. And with that, I'm going to say that it's a street. And as you can see, it starts to generate down here for us. So it is recognizing it, similar to what we had an issue with Ag Assault. They did come up here and put it in North Little Rock. So that's where I say be careful of what you're looking at. Understand some of the limitations of what you're using. But with that, our height can be just the count itself. And since a lot of them had smaller count sizes, this will help. There we go. We can see where some of the higher street segments are. Keep in mind our high here was 5, and we had a couple with 5, but as we zoom in, we can see where that's located on it, and we can even zoom in and see, here we go, 6400 Colonel Glen. So we can see that. It makes sense, and if anyone's familiar with Little Rock, the University of UALR is right in here. So, not shockingly, we have a fair amount of crime around the university there. But this is an easy way to just visualize some of your concentration of crime at the 100 block. Like I said, be careful of what you're looking at. It can kick things over based on the address itself. This one put it in North Little Rock, even though it's not. That's because we changed and rounded it to 100 blocks. Some of these streets might not have an actual 100 block where it's 6300. It could be starting at 6301. So keep in mind that could be a potential issue and something that you have to deal with down the line if you're wanting to only display in Excel. But it's a good way to visualize the data and see where some of the high points are in terms of concentration of crime. Now I'm going to exit out of this. It's going to still be there if you ever want to come back to it. But the important part here that I want to circle back around to is we have our, and I'll just update this so we can go through it as we talk about it. So we have our cumulative percent of robbery, and we also have robbery across So to give you an idea, this is what we're working with in terms of the data itself. We have the 370 robberies that occurred in Little Rock. That is going to be used as our denominator because we know if we have equal distribution, there could only be at max 370 streets that had a crime on it. So yes, there's many thousands more of streets and blocks that could have crime on them, but given that we only have 370 reported incidents, keep in mind it's police known incidents, that is the max we could have. Yes, the 370 could be spatially distributed in different manners in terms of what streets actually have crime, but it could only ever be 370 given the number of robberies reported. So that's always our maximum. So if we make that our denominator when we're looking at the percent at the 100 block level, that gives us an understanding of how the crime is distributed across the blocks that could potentially ever have crime on them. With it, that's why we use 370 as our denominator when we're building the cumulative percent of 100 blocks itself. So we know that 78% of the potential street segments or 100 blocks for robbery actually had crime on them. That means 21% did not. We know that crime did concentrate on a smaller portion of them. So if we come down here where it's about 40%, we see that 18% of the potential, or 18 to 19% of the 100 blocks account for 40% of the robbery incidents in Little Rock. So we start to see some of that concentration here for us. And we can go through and clean up the data and categorize it to make charts for this that could display the numbers and cross sections of that. It's not that difficult to take what you have now and recategorize it and kind of build up the chart and visualize it a bit easier. But this is the first step. When we view law of crime concentration and even the 80-20 rule with risky facilities, we oftentimes think it's very difficult to analyze and understand what's going on. The purpose of this video and the ones that I've been doing in Excel is to show that data and crime analysis can be done in Excel, and you can gain valuable insights without having access to expensive softwares or learning intensive softwares or programs or coding at the front end. That's the purpose of this. The next video that I'm going to get into, it's going to combine the 80-20 rule of risky facilities with our 100 block of law of crime concentration mindset. If we understand where facilities are located, and we can do a similar process here of tying them to a 100 block, we can then do a cross-reference to look at what blocks have a higher percentage of whatever crime we're looking at, and what businesses are located there, or institution or organization, what's going on that street. We can combine multiple data sets again from an 80-20 perspective, but we're going to apply it to almost a 100 block law of crime concentration aspect. So we're going to view certain blocks as risky, and then we're going to look at the factors that influence risk on those, of why potentially they are higher for certain crime types. With that, that's all I have for this video. If you would like greater depth, let me know. I will come back to this and make some other ones as well. If something's not clear, you'd like me to spend some more time, let me know. As you can see that I did in this video, it took me a couple times when I was making the chart, how I wanted to display it and come back and do it. Trust me, it took me a week of fiddling around of what worked best, what didn't work, where some issues were, just based on crime data itself, because Excel has tons of videos out there on it. But with crime data and what we're trying to do and visualize with it, you have to tailor it for what you want. With that, if you would like me to tailor a video similar to this, let me know, and I will gladly put it together. If not, enjoy and have a good one.